Okay, hope you guys are having a great start of the semester so far. It goes quick, so we'll just get going here. A set is a well-defined collection of objects, well-defined. So they usually have something in common, although to be honest, they probably really don't have to. So like a set could be even integers, and so, or maybe even integers between 2 and 8 or something like that. Or it could be a list of math symbols like square root, factorial sign, adding, equal sign, multiply, multiply dot. I mean, it could be a set of anything. And we usually use the little curly guys to define it. All right, this symbol right here kind of looks like an A, means that it's an element of it. So this is saying 3 is an element of these. These things in here that are on the list or inside the set are called elements. So 3 is an element of that. This guy, when it has a slash, kind of like equal to and not equal to, this guy is saying that's not an element. So 4 is not an element of that set. So that would be a true statement because it's saying 4 is not an element. Okay. So here, set A are these numbers right here. 11 is an element that is false because 11 is not on the list. 25 is not an element of A. That's true because it's not. 10 is an element of A. 10 is an element of A, which is true. Sometimes a double negative gets a little tricky if there's a negative. So what I always do is I always kind of think, is 25 an element of A? And the answer is false, right? It is not. So then if there's a not in it, then it's true. I don't know if that helps you or not. You guys can decide. All right, empty set. Have to be super, super careful with the empty set. So the empty set, we either define it as that, or we literally make a set with nothing in it. Okay. And you might be like, well, what's an empty set? Well, an empty set might be, cats that Julie owns. Okay. Everyone okay? There are no cats. I don't own. I have a dog, but I don't have any cats. So this is the empty set. And the empty set is kind of always present because it's kind of like you find a little patch of like air or space. Okay, so every set has kind of a little empty part in it. But if the answer to the question is completely empty, we either use this guy or this guy. And be super, super careful. The answer is not 0. If your high school teachers use that as a 0, that's bad. It is not a 0. This is the empty set. So for example, 0 does not mean that. If I do this and I put it inside the set, whoa, that's not an empty set, because do you see how there's something inside here? Remember when I had this set of math symbols? Well, what if I add the symbol for the empty set inside? That is a symbol. And so here there's 1, 2, 3, 4, 5, 6 elements. If you put this guy inside here, do you see how you have one element in there? The empty set is either just air inside here, like just space, or this guy. You can't put them together. Okay. And you can't put a 0 in there either because, 0 is a number. This would have something in it. Just like up here, if I started this with 0, well, then that counts as something as far as an element goes. So one or the other, don't do both. Next page, they kind of highlight that. This is 0, this is the empty set, this is a set that has something in it, so is this. All right, so let's look at this one. How many elements are in each set? Okay, so this guy, when we put it in front, is cardinality. So it means like the number that are in set A. So if set A is, plus, minus, multiplication, division symbols, okay, it's a set of those symbols, then the number in A would be 1, 2, 3, 4, because there's 4 elements in there. It's called cardinality. It just means you count. So here, n of A, right? So n of A would be 3 because there's 3 elements. Here, the number in B, okay, positive integers, 0 is neutral, so that doesn't count, less than 5. All right, so integers, 1, 2, 3, 4. Let's see, less than 5, 5 is not included. And 0 is not positive or negative, it's neutral. So 1, 2, 3, 4. So that looks like it's 4. And then here, the number in C, there's one thing in there. So that would be 1. All right, let's look. Equal, they have to be identical. Order can move around. Equivalent is kind of a weird one in sets. Equivalent means they kind of just have the same number of things because it's like there's a 1-to-1 correspondence. So like if I have A, B, C, and say set B is 1, 2, 3, they're definitely not equal, right? I mean, they don't, they don't look the same. They're not the same, but they are equivalent because there's a one-to-one correspondence between these. So basically, if the number in say A, which is 3, and the number in B is 3, those would be equivalent. But equal, they have to have the same thing. So this is what? 1, 10, 100. That's good. So that would be true. Let's see here. We have 32, 33, 34. Nope, this guy has an extra guy, so no. Positive even numbers, less than 8. Okay, so positive, again, even numbers would be 2, 4, 6, and 8 is equal to, because it has that line under it, so that means 8 is included. So let's see, I have even numbers, positive 0 is not, it's neutral, not positive or negative. So do you see how that does not equal? Because this guy has 0, so that's false. And then here I have what, 3, 5, 7, 9, 3, 5, 7, 9. Yeah, those are equal. Okay, true. We don't do repeats on sets either. So we don't write like A, B, 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 it's just one of everything. All right, let's see. Set builder notation. This is called roster method when you list it. Kind of like if you ever played sports like, Sue and John and Jose and Isette and Deshaun, and so I just kind of have my list of players like a roster method. Set builder is when you write a formula for it. So you kind of say X such that, and then you give it a rule. And usually you kind of define your variable at the beginning, and then this means such that, and then you put a rule over here. So I might say X is an element of, say, the natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9 forever. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Integers have nice positive and negative numbers. But I say X is an element of the natural numbers. That's my definition. And my rule might be that it's between, let's say that right there. Okay. Now, again, this guy means it can equal it. This means it has to be less than. So if I want to do this in roster method, I'd be like, okay, 3's included. 4's in between there, so that's included. 5's in between there. 6 is in between there. But see, 7 can't be in there because it can't equal. So that would be the roster method, but this would be set builder notation way of doing it. So here, X is a whole number between 7 and 10. Now, it doesn't say inclusive or exclusive. So since it just says between, I'm going to be exclusive, meaning that the ends are not included. Okay. Because it says between, it doesn't say or equal to. So I'm excluding exclusive. I'm not including the ends. So the answers would be what? 8 and 9. If it said inclusively, that means you'd include the ends. So that's kind of the elements I'm looking at. All right, let's look at the next one. Okay, subsets. Sometimes students have a hard time with this. Subsets are like, we use the word subset in the English language, but a subset is like a part of a bigger thing. So for example, DMAC is, kind of a big organization, but within DMAC, we have little things, right? Like we have, our security people, we have administration, right? We have the president's office and VPs, and then we have faculty, and then we have part-time people, some adjuncts, and then we have our custodians, and we have our librarians, and we have the bookshop people. I could keep going, right? There's tons of subset of DMAC. The best way I could describe this, it's kind of like less than or equal to. So when you're a little kid, remember how 8, is less than or equal to, or just less than in this case, but it could be less than or equal to 10. So the bigger thing goes to the right. The bigger number goes to the right when you do less than, and then the smaller goes over here. And so you can do that with sets. Like set A could be less than, and it could be just less than, or it could be less than or equal to. All right, so we usually do less than or equal to, which is just a subset. If I say it's a proper subset, that means it's truly less than it. It's not equal at all, or that's not an option. All right. So for example, 3, 4, 5, 6 is a subset of this. And if I draw a picture, B is 2, 3, 4, 5, 6, 7, 8. This is set B, and it's the bigger one. And A is what? 3, 4, 5, 6. Do you see how it's all inside of it? So it's all inside of it. So it is a subset because it's less than or equal to this guy. Okay. So let's look at these. All right. So is A a subset of B? All right. So here's B. Again, we want the larger. It's like, do you see how that's similar to less than or equal to? Okay, just curvy. All right. So B is the bigger set here for those up there. This is 1, 2, 3, 4, 5. Is A, which is 1, 2, 3, 4, less than or equal to it? Yeah. So that's true. That's a subset. This is a proper subset when it's truly less than it. And it is because the 5 is not included. So that's truly less. Okay, the other way around is saying that A is your big guy. Okay, so A is on this side. So this has to be the bigger set. 1, 2, 3, 4. And this guy has to be the subset. So here I have 1, 2, 3, 4. But do you see how that rest of that goes outside? There's 5. So B is not less than or equal to because it goes outside of that set. Here's set A. Here's set B. B has part of it, but it also goes outside. False. And obviously it's not less than or equal to either. So that's false. Okay. So that would be subset. Over here, it's saying that A is a subset of B. So, but it also has the equal to, right? So set B is the bigger one, which is what, 5, 6, 7, 8. And notice A is equal to it. So this means less than or equal to. So that's still true. But here, do you see how it's not less than? This is kind of like less than. That's a subset. So this is a subset. This is a proper subset. That guy's false. Okay. And let's see down here. Again, the bigger one. So what do I have? 1, 2, 3, 4, 5, 7. So 1, 2, 3, 4. But do you see how it's missing the 7? So again, if I draw the bigger set over here and I circle my 1, 2, 3, 4, what else do I have? 7. It's not a subset because part of it is outside. So that's going to be false. Okay. All right. Now, this is important. For every set, the empty set is always a subset, and it's always a subset of itself. Okay. So what that means is if I have, A, B, C, D, E, there's a little space right here with just some air in it. And I mean air, like breathing air. And so there's always a piece where there's nothing in it. That's the empty set. So the empty set is always a subset. And because we're not doing a proper subset, we're just doing a normal subset, this guy. So that's less than or equal to. So A, if A is ABC, is always a subset, well, I use the same letter there. That might be confusing. Let me use numbers here. So say this is 1, 2, 3 is A, and say B is 1, 2, 3, right? A is, a subset because it can equal to. So I could call this set A, and A again. A is a subset because, again, the equal part, not the less than part. All right, how are we doing on time? All right. Okay, how many subsets are there? Okay, so if we are in class, in a normal face-to-face class, I would have you guys brainstorm this. All right, so if you have 5 and 6 subsets, so here's your circle, 5 and 6. Students would usually say 5 by itself, 6 by itself, and 5, 6. So that's good. You get 5 by itself, 6 by itself, and 5, 6. But I would tell you you're missing something. And so then usually students would be like, oh, there's always a piece of air, right, that you could breathe that has nothing in it, some air. And so that's the empty set. So the empty set is always a subset. So there's 4 here, 4 subsets of the big set. And then if we look at the next one, again, I'd have students. So then students would be like, oh yeah, X by itself, Y by itself, Z by itself. And then usually students would do, X, Y, what is it? X, Z. Am I missing something? Let's see. Oh, Y and Z. Sometimes students will ask if order matters, and the answer is no, because you can just move stuff around. So students would be like 6, and I'd be like, okay, you're missing a couple. And then they'd be like, oh yeah, we could do all of them, which is 7. And I'm like, you're still missing something. And then they could be like, oh yeah, I could have the empty set. Okay. So again, you can either write the empty set like I did up here, or you could just do air, right? Just a bracket with nothing in it. Don't put anything in there. So notice here we get 8. So then in class, we usually try to look for a pattern. So if you have one thing, like say you just had, I don't know, the square root sign, that's your set. Say this is set A. You'd be like, okay, I could have square root sign, and basically I could have the empty set, right? So that would be 2 things. And so students like to look and they're like, ooh, 2, 4, 8. So looks like maybe there's a power of 2 thing going on here. And here's the formula right here. right? So we'll move on with this in just a second.